go ahead and get started here. So we're doing chapter P. This is section 5, factoring polynomials. Factoring is going to be the opposite of what we did in the last section, which was to multiply them out. All we're doing is trying to go in reverse. Where did this come from type thing? So, here are our objectives. Hopefully we can get through them all.
13.
Yeah, you could take, because some of these I don't want to leave up. There's no point for them. They're just definitions. So in this case, factors of polynomials expressed as a sum of monomials. So when we have a polynomial, it's just a bunch of sums, right? This term plus this term plus this term plus this term. When we factor it, we want to change it so that it goes from sums to products. So it's some number times some number times some number times some number. Now, please be cautious when I say that, because a lot of people think it really is a number. But even though I have a binomial like this, that's a number. Because of the closure property, the one we never talked about, you know, this represents a number. I don't know what the number is until I know the value of x. So what we're trying to do is go from like 3x squared plus 5x minus 2 to something where it's a product of a bunch of things, like that. Make sense? So that's what that slide is saying. Let's continue. The greatest common factor, I think we all know about that guy. We call him the GCF. All right, so let's try to factor this bad boy right here. So for starters, I want to see if they have anything in common that I can take from them. So for starters, I see that those are both even numbers. So I can probably factor out the 2. Now, is everyone okay with that activity, or should I break it down all the way?
Wait, can you please repeat that again?
Okay, tell you what I'll do. I'll break it down, and if people got shortcuts, then you can use those. Okay? It comes through practice. It comes through practice. So let me show you what's supposed to happen. You're supposed to take these two, and you want to break them up into its prime factors. So when we're talking about 10, 10 is simply, what is it, 2 times 5? And then x minus 2 times 2, x. And when I'm factoring, I want to make sure that I take all of the different factors from each of those terms that they have in common. So in this case, they both have a 2 in common, yes?
Yes.
What else do they have in common?
2x's.
The 2 x's, so I can take that, and I can take that, thank you very much. So I'm going to pull those out, and that becomes 2x squared out here. So what I'm factoring out is a common factor that is 2x squared. And then what I'll do is I'll give them their change back. So this first term had a 5x, and the other one has a 2 left over. So I've factored out the common factor.
Is that for every single one?
No.
Okay. So is it mainly like toward a specific exponent, or?
Is this just something that you're going to have to learn to do to figure out where they go? Because you can have a polynomial that is factorable into 2 binomials. But to make that simpler for yourself, you can also take out a common factor that will minimize the size of that. Okay? It's just a technique to try to make the number smaller so we can do them in our head. Okay? Questions on this problem? All right, let's go. Here we go. Oh, like this one. Here's another one. They want us to factor this problem. I'm going to use my mouse because I can't reach. I'm vertically challenged. What do they have in common?
The x minus 7?
Yeah, x minus 7. That is a number. We're going to take that number out. X minus 7. And then I'm going to give back what they have left over. This first term has a 2x. The other term has a 3 left over. So there we are. Again, factoring out the common term.
You make things so simple than just other teachers don't. Yeah, it's like too complicated.
That's the goal. Math don't like hard.
Yeah, like this.
Don't like that.
Math is lazy. All right, can I change this slide?
Yeah.
Yeah?
Yeah.
Okay. See, what else we got? Oh, factor by grouping. Sometimes we're going to have polynomials that are a little bit larger than the square, because I'm kind of used to those quadratics, right? we can FOIL in reverse, but sometimes you'll have something that's like to the 3rd degree, and using our old reverse FOIL method is just not going to happen. Kind of like the one I was staring at a minute ago there, making sure I FOILed it out correctly, because I'm not used to those. You can't FOIL in reverse either, so it kind of stumps you a little bit. So we use this process called factor by grouping. And let's take a look at what that looks like. So here's this problem. Obviously, I can't FOIL that in reverse, right? A little tougher. How you break this up is going to become a technique that you're going to have to, hone, I was going to say. You have to hone yourself. Personally, I try this first. I'll just split it right there. Okay, so I've just gone right down the middle. And then what I'm going to do is I'm going to treat these as 2 separate things. Okay? And what I'm going to try to do is try to factor these. So as I look at the first piece, what do they have in common? X squared, don't they? And what would be left would be an x on the first and a 5 on the second. Yeah? Now looking at the other part of it, looks like I could probably factor out a -2. So I got -2 there, which means you got x and a +5. Why a +5? I took that negative out, didn't I? And now as I look at this, oh, look at that. They got a x + 5 in common. So I could factor out that term, x + 5, and I'm left with x squared minus 2. And now it's factored using the grouping method. Now, again, that's my method. Don't be afraid to group them differently. Maybe you want to group x³ minus 2x and group plus 5x squared with the -10 for whatever reason. I don't know. So looking at the blue part, what can I factor out? I could factor out an x, and I would be left with x squared minus 2. Looking at the green part, I could factor out a 5 maybe?
Yes.
So plus 5, that would leave me with x squared minus 2. Oh, they got an x minus 2 in common, or x squared minus 2, and I would be left with x plus 5 at the end, which is the same thing as before.
Well,
That's crazy.
will MATLAB care if we flip them?
MATLAB should not care, and the reason is multiplication is commutative. It doesn't matter what order I multiply them in, so it shouldn't matter what order I put my 2 products in.
I thought you were going to say the computer doesn't have feelings.
No, it doesn't. Oh, I had a small breakfast. Oh yeah, but I'm also talking. I don't want to be like, not on the second recording. Like, look, Mom, this is my teacher. Questions on this problem? We're good? That would be just ridiculous, right? Like, maybe I don't want you in there. Can I change the slide?
Yes.
All right, cool. This is a factoring technique for those binomials that have a value. Don't try to make sense of it. I will explain. But if you want to take a picture and try to make sense of it, when we were doing Algebra 1 and second year algebra, we factored mainly in the form of x squared plus bx plus c. There was never a number there at the beginning, so we always knew, oh, we go x, right? But we know that there's going to be, an a value there. So this is where that O plus I piece comes in. That makes it a little easier with the other problems, but I'll show you how this works. So I have this up there, right? And this is going to be a lot of, this is, as they call it, where does it say? Trial and error. Oh, yay, trial and error. Okay, so let's go back to here. Here we go. So, hey, but this one we can do. This one's not like that one. Obviously, the only way to get x squared would be x and x, right? And then, of course, I'm trying to figure out two numbers that are going to multiply to here, add up to 13. So I can sit there and think about them. Let's see here. 8 and 5?
Yeah.
All right, cool. So that's not bad. So that example was not good for what I wanted to demonstrate. But there you go.
Yeah, 8 plus 5
Wait,
is
can we?
40, right?
Right, because I have to multiply to 40, but the two numbers should add up to
13.
13. So everyone's okay with that, right?
Yeah, can we add a more complex one?
Right. Well, I want to make sure everyone understands this part. That we pick the last two because they have to make the last number. Correct? All right, cool. So we don't have an example.
You should make, make your own.
Man, you know what? When I make them up, they never work. Let me
Look one up.
whip out this handy dandy notebook. I want something that's going to work for us. So let's go to, what is this, P5? P5. Okay, so let's go ahead and do 2x squared minus 7xy plus 3y squared. Okay? Oh God, why did I ask? This is a quadratic, which means I should get two binomials, correct? So here's the way we're going to use our guess and check. In order to get this product, it has to come from the first two, correct? So here and there. Well, what's the only way to get two? A 1 and a 2, right? So this is going to be a 1x. This will become a 2x. Now, I also know for a fact that the last two produce the last value here. So what's the only way to go to 3? 1 and 3. So I'm going to go with a 1 and a 3, and it should be y and y, correct? So let's see here. What I'm going to do is I'm going to check now by using my FOIL method. So this is going to, that's not what I wanted to do. Let me switch these positions.
See, so it does not.
I just wanted to, well, let's see if it works. But it does matter, but this is why it's a trial and error. Let me put it back because I'm being a jerk about that, aren't I? You already wrote it down probably?
Yeah, I wrote it.
I just erased it.
Let's erase it one more time.
1y.
Wait, 2y.
You wrote 2y instead of 1y.
Why did I do that?
Where did it go?
Where did it go? Okay, so I have this. Now, remember, rules still apply. This is positive. The only way to make this positive was two positives or two
Negatives.
and of course this will tell me what it was. Right? So two negatives. Now here's what I'm going to do. How much is that?
3.
That is negative 3y, correct? 3xy. Yx, And then this product is negative 2xy. If I combine them, do I get the middle term? No. So guess what? What should I have done with the 1y and the 3y?
Switch them.
It should have been the other way I suggested.
So,
So,
I wrote it that way.
so x minus 3y, 2x plus y. You guys okay with me dropping the ones?
yeah.
Okay, so now I'm just going to double check that, hence the trial and error. This is going to give me
XY.
a positive xy, correct? Oh, that should have been minus, my bad. That's going to give me a negative xy, and this is going to give me a negative 6xy. If I combine them, do I now get my negative 7? Yes.
Can you like go over like
That's pretty easy.
because like that's what confuses me.
Go over the signs?
Yeah, the signs. Like that's what confuses me.
Oh, well that's not a big deal. Let me make sure I can erase this first. Or anyone still writing that down?
Yes.
Yeah. Hello. It's me. Good? Good, good, good? All right, so, no? Shh. Are we done with this slide? Okay, good. So I want to make sure.
I'm just playing.
I'm not.
We've had those emergencies.
I know.
Where someone's like, no, I'm not done, but I'm having a conversation over here, and they're like, I'm not done. I'm like, okay. First, insides, outsides, last. Okay.
Whoa.
Inception. My bad. I bumped the button down here. So here's what we were saying about the signs. This is positive, right? Now, there's no reason why they should ever be negative in the front, right? So I can just say that's a plus and that's a positive number. Blah, blah. Who cares what they are? But here I have to stop and think. The last number, this, came from the last two. That 3y is positive, isn't it? So I have to think to myself, the only way to get a positive is if the two numbers in the blue spots, that means this guy and this guy, they were both either positive or they were both negative. Now remember, to get the middle one, I'm going to add this product and add this product. Correct? Which means that once I add them, I'm going to end up with something that is negative. If these were positives, would that negative situation ever happen?
No.
So that means that those two signs should be, boom.
Now it looks like a smiley face. The eyes are a little close together.
Difference of squares are awesome. If you can identify difference of squares, you can factor them like this. Because, remember just like we did for first ones and the last ones only? Well, we're going in reverse. So if I can identify the difference of two squares, then they're going to factor into two conjugates. They will factor into its conjugates. Does that make sense? Not like, a little softer, a little more kindness. All right, so like this case, can I express that as the difference of two squares? Well, what's the square root of 36? And the square root of x squared? Is there a square root of 25? 5. Good. So now I've identified A and B. So this will look like this. 6x minus 5, 6x plus 5. And I'm done. Because I was able to write them as a difference of two squares, that means that they're going to factor into two conjugates.
What does that mean?
This inside being A, that inside being B.
So if you have the minus and the plus sign, is that only because
It's a difference of squares.
minus and 5? What if it was a plus? Is it the same exact thing?
No,
Okay.
no.
So if it was
This
plus
only works if it's the difference of squares. Now, let's stop and think about this real quick, okay? Remember what you said about those signs? How do I know? It's that same idea. This last number came from the last two positions, correct? So, if this was a plus, like you said, that means that these would both have to be positives, correct? But, here's what happens. 6 times 6 is 36x squared. This will give me 30, and another 30 will give me 60. JK. 60 plus 25. Which is not what we started with. Is it? So, only the difference of squares can be broken up into conjugates. And that's why this slide only had the minus version. There's no plus version. There's no plus version for squares.
So it will always be.
If it's the difference of squares, let me say this clearly. If you can identify them as a difference of squares, they will make you conjugates. What I did in the red. I did my test using the red part. I broke it up into a difference of two square numbers. Just like that. And then what I said was, okay, what's the square root of that bad boy? Well, the square root of 36 is 6, and the square root of x squared is? And then what's the square root of 25? And that's where the numbers came from.
So one of them can.
Yeah, if like this was 30, then I'm done. There's nothing to do.
So it's like you're trying to find the square root of it. Like,
Yeah,
is that
because
that's how you check it. Like that's how you check to see if
technically, yeah, because what am I doing with them anyway? I'm squaring them. So I really am doing the square root. Okay. Thank you for asking that. Factor completely. Okay. That is not the difference in squares, right? It's fourth degree.
But it can still be done.
Nice and loud?
But it can still be done.
Let's see if it could still be done. I want to make sure that I can write them as a difference of two squares, don't I?
Yeah.
So, is there a square root of 81?
Yeah, 9.
9. Is there a square root of x to the fourth?
Yes.
Yes, that's x squared. Is there a square root of 16?
4.
It's 4. So now I've done it, so I can write them as two conjugates. So I've got 9x squared minus 4 and 9x squared plus 4. Right?
Right. That would be it.
Why are you writing when I'm writing? You're missing things. Because, wait, there's more. As I look at the first part, oh my God! That's also two squares, isn't it? That is like, let's see here, let me try this real quick. That could be 3x plus 2, 3x minus 2. Do you see it?
Do you see?
Now, and of course the last part, what would that become?
3x plus.
There's a plus between them, so it just is.
Oh, I never understood that.
So the answer from Joseph.
But wait, no, there's no more. I'm just kidding.
I was like, what?
All right, go ahead and copy her down. Questions I can answer for you on this problem? The Shake Jumper?
So,
Go ahead.
because it's a plus.
Because it's a plus,
Can't break it down anymore.
remember, it's the difference of squares. If this is the difference of squares, is this a difference? No. Okay. Any other questions? Just do it.
And do these,
Go ahead.
this one require it to be, require it to be like,
I can't hear you because there's other conversations going on. I wish I could answer your question.
is this, sorry, I can't even word this right. So is this the way that you can put it into any like form, like it could be like a positive on the side and negative on the side? Or like, do you have to have it in a specific order? Like, can it be the, what was that word? It's a C word.
Commutative?
Yeah, that. Can you put that to
If I wanted to annoy the teacher, yeah, I would probably like take this guy right here in the middle. Let's see if I can get just him in the middle. No, I can't. But yeah, I know what you're saying. You could do this.
It doesn't matter what order it is, that's what
No, that would annoy me, but again, you are throwing to
So
math
do
lab,
it then.
so it shouldn't matter how you put it in there.
Do it if it annoys you.
What's up?
If say negative. Wait, never mind. That doesn't make sense. I got it. I like answering that question.
That's good. That's good. Critical thinking. And next, can I change it? All right, let's see what we got here. All right, so now notice this. This is a little different. How's this different? Because see how there's a plus here? Okay, so I want you, no, don't write this down yet. Let me talk to you first. Here's the difference. Because it's a difference. Notice it's a difference of two integers or two numbers or whatever they are. Here, they're inside of the parenthesis and the entire quantity is squared. Outside of the parentheses, inside of the parentheses. Okay? Here I'm repeating this part twice, correct? This is A times A minus B times B. While over here, it's really just A plus B times the quantity A plus B. So it's very different. Okay? That's why I can have a plus here, but not with the others. Okay?
because they're not squared in.
It's not the same idea. Exactly. Now, these,
Oh, I was.
for these, did you want that? Hey, you know where else it is?
Online.
YouTube. Immortalized. So anyways, let's talk about these two. For here, we've got the difference of a quantity square and the sum of a quantity square. And if you want to be able to factor those, here they are. Now, anybody recognize those numbers?
Yeah.
Yeah, from where?
Math class.
From math lab.
We solved.
This is
Special products.
b to the second. B to the second. Where'd you go? Where did you go? To the second. 1, 2, 1. 1, 2, 1. Where did it go? Here it is. 1, 2, 1. 1, 2, 1. So they're just Pascal's numbers. Okay? But anyways, let's see how this... Is this going to clock yet?
Yeah.
How much time do I got?
1 minute.
All right, 2?
1.
Oh, that's all I need. Pay attention. Here's what I'm going to do this problem. Does the first have a square root?
Yes.
That's 4x. Does the last one have a square root?
Yes.
That's 7, right? Or it could be negative 7. I'm assuming because of that bad boy. Now, what's 4 times 7?
28.
Double it.
56.
What?
So it's factorable into those two parts. Okay? We'll pick this up tomorrow.
Any homework?
Yes, there will be homework.